Hello, Willard fifth graders. Today, I want to think about our solar system and the size of objects in our solar system. It is hard to think about the size of the planets and the sun because they are so huge. It's difficult to comprehend. It makes my head hurt. Now, I have a trusty Google document that you can take a look at that shows the planets and their relative size, and this link is on my Canvas page. But I've printed it out. Here it is, right here. Are the planets listed in order? Well, what is the order of the planets in the solar system from the sun outwards? Well, I learned a tricky way to remember that by saying, "My very eager mother just served us nachos." The first letter of each word in that sentence is the very first letter of the planet in order. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So you might have a similar trick to remember the planets. This is the one I use. So now, let's look. Okay. My Mercury, very Venus, Earth eager, Mother Mars, just, oh, no, they're not in order. Well, why not? Well, because some of the planets are so large, they get their own page. So let me cut these out, and I'll place them in order. Okay, my Mercury, very Venus, eager, Earth, Mother, Mars, just, Jupiter, served, Saturn, us, Uranus, nachos, Neptune. Now, you might be wondering, where is Pluto? Well, whether Pluto is a planet or not has been a big controversial thing in this century. The trick is there are large, huge bodies of rock that orbit the sun very, very, very far away. These are out in the Oort cloud, very far away from the sun. And if Pluto is a planet, then so are all those other bodies of rock, and suddenly we have 100 planets or more. Whoa, that would be a very long sentence about what our mom would be serving us. So scientists, astronomers got together and they thought about what does it mean to be a planet, and they came up with a new definition. And Pluto does not count as a planet anymore. It's now called a dwarf planet, one of many in our solar system. So Pluto is not here in our cutouts. But if it were here, Pluto's diameter, the distance across its center, would be 1/20th of an inch. That's the size of a dot. Okay, there's Pluto. What about the sun? Where is the sun in our solar system? Well, the sun is 109 times wider than the Earth. So there's some math to do here. The width of the Earth on our cutout, its diameter is 1/2 inch. So the diameter, the width of the sun, will be 109 times 1/2 inch. 109 times 1/2 equals 54 1/2. 54 1/2 inches. How big of a circle is that compared to our planets? Here it is. It's this big compared to the planets in the solar system. Now, this might make you wonder. You can see when we compare the cutout of the sun and the cutout of the Earth, the sun is so large compared to the Earth. But when we see the sun up in the sky, it seems so small. I mean, you can put your hand up when the sun is in your eyes, and your hand will cover the sun and more. The moon is smaller than the Earth, but during a solar eclipse, the sun is blocked by the moon. If the sun is really so big, Why does it seem so small? Well, the reason is because the planets are not as close together as I have placed them here. What if I moved the cutout Earth to the actual distance it would be from the sun if the sun were the size of this cutout? Well, it's time for some more math. So we know that the actual distance from the sun to the Earth is 92,292,000,000 miles. And the actual diameter of the Earth is 7,917.5 miles. Now, this cutout I have of the Earth is not 7,917.5 miles across. It is actually just about 1/2 of an inch across. Okay? So that means that this 1/2 inch on paper represents 7,917.5 miles. So 1/2 of an inch on my paper is equal to 7,917.5 miles. So if we take this distance and multiply it by the ratio that 1/2 in our model is going to be equal to 7,917.5 miles. So 92,292,000,000 miles, and multiply that by the ratio that 1/2 of an inch is equal to 7,917.5 miles. And we do the math. I've already done the math. I have done that on a calculator. And I then converted the inches into miles. And you get that I need to place this picture of the Earth 92 miles away from the sun. So I need to place this picture of the Earth 92 miles away from my cutout of the sun in order to show the actual distance between the sun and the Earth if the Earth was this size and the sun was the size of my cutout. Now, that is very far away. That is roughly the distance between Pasadena and Santa Barbara. It's just about the distance between Pasadena and San Diego. That means the Earth is here in Pasadena, and the sun cutout is just about in San Diego. That is very, very far away. And that is why the sun looks so small up in the sky, because it is so far away. So these pictures give us some information about how large the planets are relative to one another. But is there some other way that we can think about how far away they are from each other? Well, sure. All we need is this. I've done some more math because in order that I don't run out of sheets of TP, I need to decide how long one piece of toilet paper is going to represent. And I've decided that one sheet of toilet paper is going to represent 15,534,280 miles. That's a really weird number. I picked that really weird number of miles because it is a nice, perfectly round number of kilometers. Most of the world measures distance in kilometers, but the US does not. 1 square of toilet paper is going to be equal to 25 million kilometers. 25 million kilometers or 15,534,280 miles. Now, if this square of toilet paper represents such a huge distance, how big would the sun be? Would we be able to see it? Would it be big enough to be able to see? Well, I did some more math, and I figured out that the sun would be just less than 1/4 of an inch wide. So I have this yellow bead right here that is just over
1/4 of an inch, so it's too big. But it's close. So I'm going to use this yellow bead to represent the sun as I start creating our model.
So I've made some calculations. For each of the planets, if one sheet of toilet paper is equal to 25 million kilometers, well, I know how far they are away from the sun, so I calculated how many sheets of toilet paper do I need to have between the sun and that planet to show how far away it is. So this is included as a link on my Canvas page, but here's my TP. There's the sun, and I know that Mercury, the planet that's closest to the sun, is 2.32 squares away. Okay, so 2.32, that's about a third. 0.32 is about a third, so I'm going to say that Mercury is right about there. So there's my dot for Mercury. My dot's too big, but my sun is too big too. So there's how far Mercury is. Now, the next one, Venus, is 4 1/3 away. So, move this down, 1, 2, 3, 4 1/3. Boom. There's Venus, and the Earth is 6 squares. 1, 2, 3, 4, 5, 6 squares. 1, 2, 3, 4, 5, 6 squares. So there's the Earth, and Mars is just over 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's off of our view. So over there is Mars. So let's see. Sun, Mercury, Venus, Earth, Mars. The next one, Jupiter, is 31. Okay, I can't do any more on the table. I'm going to move onto the floor. Okay, I'm in the science room. It looks really different without you guys here. A lot of empty tables, but I've rolled it out now. So, there's the bead. That's our sun. Our first dot is Mercury, then Venus, and then Earth, and then Mars. And Jupiter is the next closest planet. I know I skipped over the asteroid belt, but I'm just looking at planets right now. The next closest planet is Saturn. Now, here's the trick. The next closest planet is Uranus, and that's 114 plus squares of toilet paper. Saturn was at 57 squares. So I need to go out in the hallway. All right, Willard fifth graders, I have finished putting together my model. So I'm just outside my classroom. The stairs that come down, I'm right about in front of the stairs. There's our sun. And then Mercury, Venus, Earth, Mars. Jupiter is just about across from my door. Saturn is right about across from the end of my bulletin board. Uranus is just shy of the health office, is right below the nurse's bulletin board. Neptune is right below the tree in the hallway. And I stuck on Pluto because we like to think about poor little Pluto. Pluto is right in front of the door to the main office. So there you go. We made a 2-scale model of the solar system. And so why, when we look at the sun, or we look through a telescope at other planets, why do they look so tiny? Well, it's because they are so far away.
Well, all right, Willard Wildcats. I hope that you were able to take something away from this video, even if it's just, wow, the sun is really huge compared to the Earth, and the Earth is very, very far away from the sun. And you have all the information now. you have all the information you need to do this yourself. All you need is a roll of toilet paper, and the numbers I have included for you on my Canvas page. And if you want to get a copy of these cutouts for all the different planets, what their relative size is to each other, then that is something I can work at getting to you, either available for you to print off, or even better, something that you can have and just get the papers and cut them out yourself. And the information is in this video for you to be able to figure out how big the sun needs to be if the Earth is a half an inch wide. So, my friends, I look forward to seeing you next time, where we'll think some more about astronomy. Bye-bye.